Imagine putting on special glasses, not just any glasses, but ones that grant you a superpower, and suddenly seeing the world in a completely new way, a perspective shift so profound it changes your understanding of everything around you. It's like stepping into another dimension. Not just in color, but in heat. You're no longer limited by what your eyes can see. You're seeing the invisible, the thermal signatures that paint a different picture of reality. With thermal imaging, you can spot the warmth of a friend's face, a radiant glow that tells a story of life and energy. You can even see the heat radiating from a cup of coffee, a comforting beacon in a cool environment. You can detect the cold draft from a window, a chilling reminder of energy loss and the unseen forces at play in our homes. Or the heat left by your footprints, ephemeral markers of your passage, a fleeting testament to your presence in a space. This is possible thanks to infrared or thermal cameras, sophisticated devices that unlock a world beyond our normal perception. Instead of capturing visible light, which is what our eyes do, these cameras detect the heat energy that everything emits, a constant stream of infrared radiation that surrounds us. They translate this invisible energy into images we can see, converting the language of heat into a visual narrative that our brains can understand. Revealing a hidden world all around us, a tapestry of thermal signatures that adds depth and complexity to our everyday experiences. Firefighters, electricians, and doctors, professionals in critical fields, use this technology to solve real problems, problems that would be impossible to tackle with just the naked eye. Seeing through smoke, allowing firefighters to rescue people and save lives in the most challenging conditions, finding overheating wires, preventing electrical fires and ensuring the safety of our homes and workplaces, and spotting illness, enabling early detection and treatment, potentially saving lives and improving healthcare outcomes. By understanding how thermal cameras work, we unlock a new way to explore and protect our world, enhancing our capabilities and safeguarding our future. Let's dive into the science behind these incredible heat-seeing cameras. Let's uncover the principles that make this technology so powerful and transformative. Thermal cameras offer us a unique perspective, allowing us to see what is normally invisible to the naked eye. They detect a specific type of light that our eyes simply aren't equipped to perceive. This invisible light is called infrared radiation. It's a form of electromagnetic energy, emitted by all objects as heat. The light we see, the vibrant colors of a rainbow, is just a tiny, tiny part of the vast electromagnetic spectrum, a continuous range of all possible frequencies of electromagnetic radiation. This spectrum also includes radio waves, used for communication across vast distances, microwaves, which heat our food, and X-rays, used in medical imaging to see inside our bodies. Infrared sits just beyond red on this spectrum, residing in the area of wavelengths slightly longer than what our eyes can register. This means infrared has longer wavelengths and therefore carries less energy than visible light, making it imperceptible to our vision. Because of these longer wavelengths, we can't see infrared with our eyes alone. However, we feel it as warmth radiating from the sun on a summer day, or the comforting heat emanating from a crackling campfire. In fact, everything above absolute zero, the theoretical point at which all molecular motion stops, emits infrared radiation. It's a fundamental property of matter. And the warmer an object is, the more infrared radiation it emits, creating a direct relationship between temperature and infrared output. This principle is the key to thermal imaging. Instead of relying on visible light, the camera captures the heat, the infrared radiation, that is already present in the environment. The discovery of this invisible light dates back over 200 years. It was William Herschel, a renowned astronomer, who first discovered infrared radiation. He made this groundbreaking discovery by meticulously measuring the temperature of different colors of light produced by a prism, noticing the highest temperature just beyond the red end of the spectrum. Herschel's experiment definitively proved that there's far more to light and the electromagnetic spectrum than what meets the eye, opening up a whole new world of scientific exploration. Ever wondered how a thermal camera works its magic? How does this device, seemingly out of science fiction, turn invisible heat into a picture we can understand? It all starts with a very special lens, unlike those found in your everyday camera. This lens isn't made of glass but from materials like germanium or sometimes even sapphire. These unique materials have a crucial property. They allow infrared energy, which we perceive as heat, to pass through unimpeded. This focused infrared energy is then directed onto a highly sensitive detector. This detector is filled with thousands upon thousands of incredibly small devices called microbolometers, with each one acting like a tiny, highly accurate thermometer. When the incoming infrared radiation strikes a microbolometer, it causes it to heat up even by the smallest fraction of a degree. This minute change in temperature directly affects its electrical resistance, altering the flow of current. The camera's sophisticated internal processor meticulously reads and records these resistance changes from every single microbolometer. By analyzing this vast amount of data, the processor constructs a detailed temperature map, which we call a thermogram. In this thermogram, each individual pixel corresponds to a specific temperature reading taken by one of the microbolometers. To make this temperature data visually understandable, the processor cleverly assigns different colors to different temperature ranges. Typically, cooler areas, representing lower temperatures, are depicted in shades of blue or purple. Conversely, hot spots, indicating higher temperatures, are shown in yellow or even white, and the result is a vivid, colorful image that reveals the hidden world of heat signatures all around us. It's this ingenious process that gives us what seems like a superpower: the ability to see the invisible world of thermal energy. Regular cameras and thermal cameras may look alike, but they reveal different worlds. A regular camera captures visible light reflected off objects, so it needs light to work. In darkness, it's blind. A thermal camera detects heat emitted by objects, so it works perfectly in total darkness. It can see people glowing with body heat at night, or through smoke and fog, but it can't see through glass. Infrared is blocked, so it only shows the glass's temperature. Regular photos show color and shape. Thermal images reveal heat patterns and energy flow. Each camera gives us a unique perspective, helping us understand our world in new ways. Together, they offer a more complete picture of reality. Thermal cameras give us real-world superpowers. Firefighters use them to see through smoke, find people, and spot dangerous hotspots in burning buildings. Search and rescue teams locate lost hikers at night by detecting body heat. Electricians and technicians find overheating wires or failing machinery before disaster strikes. Wildlife biologists track animals in the dark without disturbing them. Doctors use thermal imaging to detect inflammation or circulation problems. Homeowners find drafts and leaks to save energy. From safety to science, seeing heat helps us solve problems and protect lives. The invisible world of heat is now visible and incredibly useful. Thermal imaging was once reserved for the military, bulky, expensive, and rare. But technology evolved. The invention of the uncooled microbolometer made cameras smaller and cheaper. Prices dropped from over $100,000 to affordable consumer gadgets. Now anyone can buy a handheld thermal camera or even attach one to a smartphone. Homeowners, plumbers, and tech enthusiasts use them for finding leaks to checking electronics. Outdoor adventurers spot wildlife or ensure campfires are out. What was once science fiction is now in our pockets, letting everyone see the world of heat. The invisible has become accessible to all. The future of thermal imaging is even brighter with artificial intelligence. AI can analyze thermal data, spot patterns, and make decisions faster than humans. In factories, AI-powered systems detect overheating equipment and send instant alerts. In healthcare, AI can screen for fevers or spot medical issues non-invasively. Drones with AI and thermal cameras monitor crops, diagnose plant problems, and optimize farming. Smart homes adjust heating based on where people are, saving energy. Self-driving cars use thermal vision to see in darkness or fog. By combining AI and thermal imaging, we're making our world safer, smarter, and more efficient.